My name is David Makinson, and I'm a visiting professor here at the philosophy department in LSE. Logic has always had a special kind of relationship with philosophy and has been housed in philosophy departments because of the philosophical questions that arise when you do it. It's of use in, for example, the analysis of rules and regulations, which comes up a lot in legal theory, and even the application of legal reasoning, which doesn't mean that you necessarily have to formalize everything, put it in symbols, but it helps you appreciate where the crucial spots are, where the basic transitions are being made, where the weak points could arise, and how you might analyze their strengths and limitations. The last paper that I published, which was in March this year, was on belief revision and its relation to probability. Well, belief revision is very different from ordinary inference, and it only began to be studied quite recently, towards the end of the 20th century. It's because there's the necessity of making choices. When you want to abandon a belief or introduce a new belief that contradicts your existing ones but still maintain consistency in what you have, then you have to make choices between what you're going to abandon, and that doesn't arise in ordinary inference. It also has the effect of linking the study of belief theory with general choice theory, which reappears, of course, in theoretical economics and in political science. Well, there are two different kinds of conditional probability that have grown up in the literature. One is based on ordinary unconditional probability, and when you look at the extremal cases of probability 0 and 1, you get a very close relationship with classical logic of inference, logical consequence. But when you take a conditional probability in a non-standard sense, in which you allow conditioning on suppositions which initially had probability 0, then you're in an entirely different ball game, and the relationship is not with inference, but rather with revision. For that reason, I like to call it revisionary conditional probability. Well, I'm looking at some special kinds of inference rules called introduction rules and elimination rules for the logical connectives, and their relationship that or the kind of bridge that they constitute between classical and intuitionistic logic, which is a non-standard, non-orthodox logic developed in the 20th century by some philosophers of mathematics, and which differs from the classical logic.